Hey, John here. Let's talk about how you're going to do assignment number 1. For those of you that don't yet know how to use Hopper in Turing, we're going to do a detailed walkthrough of how all that's supposed to happen, okay? So the first thing we want to do is open the assignment and just simply we're going to enter in the text and we're going to submit it. So the detailed assignment submission instructions are right here. Okay, we're going to run a script called malprog .463 to hand in our assignment, and we're going to put our assignment in a directory called assign1. Okay, so this gives you a detailed walkthrough of a number of things and some things you can do if you run into a problem. Okay, the short of it is given in the assignment 1 handout, and we'll see that in a minute. Now, to access the machine, if you're on Windows, you have to install something that'll allow you to execute a command called SSH. A very common tool is called PuTTY, and inside here there's some links. Here's how to download it. You can follow the bouncing ball and install this application. Here's some ways that you can configure it if you really want to get into the details of it. You don't need to do that to use it. Only if you want to save time in the long run will you want to pre-configure it so you don't tweak the options every time you use it, right? Then down here, this goes through how to run it and connect to a machine like Turing or Hopper with SSH on port 22. You just simply type in the machine name here and click SSH. The port should be defaulted to 22. And then you hit open. When you do that, it'll open up a terminal window that looks like this. And at this point, you're just using a system called SSH to access the server. You have to type in your login, then you have to type in your password, and then you get a prompt on that machine. Now, in this walkthrough here, this paragraph here points out something. If you've never, ever logged in with the Z number that you're going to be using this semester to the Unix machines in Turing and Hopper, the very first time what happens is your account does not exist and it'll be created on demand when you first log in, okay? As a result, what will happen is the very first login, you're going to get an access denied message. That's fine. That's normal. Close the window, walk away for 30 seconds, come back and log in a second time. At that point, your assignment will have been, or your account will have been activated, okay? And then you should be able to log in. Don't type the same potentially wrong password in over and over and over and over again, because what it'll do is it will identify you as an attempted hacker and lock you out permanently, okay? If that happens, you're never going to be able to do anything, and there'll be no real error messages to let you know that that's the case, other than the fact that you'll just be getting weird errors from PuTTY, okay? If that happens, you need to do what I mentioned in the intro video. Go to the course syllabus, find the email addresses for the system administrators, right, which is over here, for those Unix systems right here, and tell them you need to either have your password reset and or you may have typed in the wrong one repeatedly. That's a different kind of an error that they will have to clear on your behalf, okay? And it's kind of a pain in the butt. When that happens, if it happens on, like, say, Turing, and you're repeatedly trying to use Turing and you get locked out, you can move over and start using Hopper if you want, because these are independent of each other. But if you end up locking both of them out, then you're totally dead in the water. So if you do abandon one because you get locked out, like Turing, for example, don't ignore that and say, oh, it doesn't matter, because what happens when you get locked out on Hopper? Again, you get nothing. So you have to have these things cleared up and reset if you make a mess of your password or something like that, okay? And that's how you do that. Now, where were we? Let's go back to the PuTTY thing here, all right? So we got the 3 links in here. There's a download, install, the configuration, how to activate your account. We just went over those 3 things, okay? If you're on Windows. If you're on Linux or Mac OS, I'll show you how to do it on my system in a second. It's really easy. You just type in one command and you're done. If you're on Windows, you need to move files back and forth between your PC and the Unix systems at NIU to make backups and everything else. You can use this thing called FileZilla. A lot of people seem to like this. Here's the download instructions on how to use it, okay? And then, or those that download how to install it, then here's some notes on how to use it. I haven't used this thing in a decade, so I'm not exactly an expert in the whole thing. I use the command line copy commands. This is more of what I would call a click festival, because you're just clicking on files and dragging them all over the place. This is a great tool if you don't really want to learn anything and you just want to move some files around, okay? If you're that kind of person, this is what you want. If you want to be able to automate something or script it or save yourself time, you can use a command called SCP, and it's described quite easily on this Wikipedia page. You just simply say SCP, and you got a file on the machine that you're running the SCP command on. And you type in use your Z number at, like touring.cs.niu.edu, and then you put in what the file name is, or the directory name where you want to put it on the on Hopper or Turing or whatever, okay? It's as simple as that. Okay, so let's look at the command line versions of how to do this, because that's what I know how to use. And if you're on a Mac or a Linux box, it's the same thing. We'll look at that in a second. We might as well look at the rest of these links while we're in the neighborhood. The Unix overview page here, these are the commands that you're going to be using from time to time when you're logged into the system, even if you use FileZilla and never ever really use it to do any development, okay? You will have to move your files back and forth, and these basic commands are the kind of things you'll have to do while you're trying to hand in your homework or tweaking something in the last minute. You'll also have to test your homework on this machine in order to make sure it works over there. I beat that point to death in the intro video. You're graded solely on the ability of the TA and myself to compile and run your program on Turing and Hopper when you hand it in. If you don't know anything at all about Unix, go ahead and have a look-see at the introduction file here. It gives you a rundown of how the thing works, how the file structure works. It's very similar to, Macs. A Mac is running Unix, by the way, and Linux is a rip-off of Unix for all intents and purposes. And the PC has, Windows has slowly evolved into something that works a lot like Unix out of necessity over the years, so that's similar. You're already familiar with the hierarchical type of thing. The command format on Unix for the command line stuff, you may not be used to this if you don't use terminal windows. You might want to eyeball this and get used to how that thing works. All right, so we're going to see Nano in a minute, and I'll run a couple of these commands so you can see how they're working and how they go. All right, so you want to eyeball this just to understand what is all in here and what these commands do, so that later on when you find, hey, I need to be able to do something, you can remember, oh yeah, I do that with the change mod command or the move command or something like that, okay? That's why these are all here. Okay, so that leaves us with the evil file names. Let's take a look at that really quick. The short of it is, don't name files with spaces in their names. Don't put square brackets and slashes in their names. Don't name files either dot or dot dot. You can't do that on Windows or Unix anyway, so I should probably remove that bullet. But there are systems that do let you do things like this. Don't do that. Don't use gigantically huge long names that just cause problems and annoyances when people have to type them in. And don't use any of these special characters when you're creating file names either. They're going to cause you problems, and it could interfere massively with the grading scripts and things like that. And if you do this and your program doesn't work, you've been warned. It doesn't compile, it doesn't run, whatever. Don't do it, okay? Don't name a file with a name that starts with a hyphen either, because the hyphen is the thing that introduces command line, argument parameters and stuff like that to almost every command that runs on Unix, including some of the programs that you're going to write yourself. For example, don't create files that have names that are hard to delete for people that are kind of naive. Don't name a file star, because what's the command to delete that? If you're not paying attention, you'll type rm space star, and you will delete all the files in the current directory. Don't name a file minus rf space tilde either, because if you actually type in rm space minus rf space tilde, it will delete all your files, including your home directory, and effectively lock you out of the operating system. That's not something kind to do. All right. If, by the way, you end up in a situation with a weird file name, you can remove it like this with this, very explicit remove command. And that will interactively say, do you want to delete this file, that one, and so on. You can look at the manual page for the RM command or just Google it, Unix RM command, and you can read about how that command works and what the -I and what the double dash means, okay? So just don't be, just don't be messy, and everything will work perfectly. If you get creative and start putting $signs and ampersands in your file names, it's not going to work in the way that you expect it to. It's just going to create trouble for everyone around you, and it's just going to be a problem, okay? So on then to assignment number 1. So here we go. Let's click on assignment 1. What are we supposed to do? Well, first thing you need to do is go through and install PuTTY if you're on Windows, or we can use the command line you're about to see, right? So these links here go to the same pages we were just looking at. There's the install instructions, and here's the walkthrough on how to connect the first time, right? What are we going to do? We're going to log in and we're going to make a directory called ComSci463. And then inside that directory, we're going to create another one called Assign1. And we're going to put our files for assignment 1 in there. Okay. Be organized. Keep your stuff, each assignment in its own directory. And you're going to need to do this in order to hand it in. All right. You need to do this just to keep yourself sane anyhow. But if you don't want to do it, you're going to be in trouble when it comes to handing it in, all right? So let's walk through this set of commands. There's a bunch of other things in here that show, here's how you list your files and how you ask what directory am I in right now and so on. I'll leave that for you to tinker with on your own. There's a little discussion about how to remove files in here. Be very careful if you're going to do a recursive remove, okay? This will be very quick and immediate and not ask you any questions. There's no, are you sure you want to do that kind of thing going on like you might see in other operating systems. This will just simply do it because you told it to do it, right? So be careful if you're just doing galactic recursive deletes and things like that. So let's look and see where we're going. We're going to open a really super simple editor called Nano. I do not recommend that you use that for writing programs. Some students do, and if you like it, knock yourself out. You're way better off learning how to use a more powerful editor of any kind than spending all of your time in Nano holding down the arrow keys to move around in your file. It's literally a waste of time. The reason we use it in demonstrations like this is because it's a very trivial editor. It doesn't really have any features of any kind, and anybody can easily learn it in about 2 seconds. Okay, that's why we use it in these videos. Move on to learning a better one for day-to-day use. Okay, so what we're going to do is we're going to run an editor. We're going to type this in. Well, I'm going to just cut and paste it like this right off the web page, and we're going to then compile it like this. So let's do that. I'm on a command line Unix or Linux system, so I'm going to type SSH. Winans is my login. Yours will be Z12345 or whatever it is at hopper.niu.edu. Okay, and I typed it in wrong because I didn't put a CS in here. So that's what happens if you type the wrong name in. And I'm going to log in like this. It's not going to ask me my password because I have special permissions and stuff set in. If you do this, it'll ask you what your password is, and you would simply set it up and type it in. Okay. Okay, so what are we going to do? If you type ls-al, that means all files, including all these with the dots that are hidden, just like in Windows and on a Mac. If you type ls-l, it'll list all your files that are not hidden. And inside here, I've got a bunch of things lying around. Let's move on to the instructions here. What are we supposed to do? First thing we got up here, we're supposed to make dir what? Here it is. Make dir ComSci463. And then we're going to do a cd into ComSci463. All right, so in this directory, there's nothing because I just created it, right? Then down here it says make dir assign1. It says type in ls, so you can see it there, ls-al. You can see the hidden files as well as this thing. Cd into the assign1 directory. Play around with these commands if you want. I don't feel the need to have to go over every single one. That's left as a task for the viewer. Run an editor and type in the program or cut and paste it, right? Like this. And the way this editor works is like the only one you write out your file. Why didn't call this save? I don't know. When you see an up arrow, the caret like that, what that means is hold down the control key and then hit O. So I just hit control O and it says, do you want to write it into LabTrain CPP? And I'm going to just hit enter because my answer is yes. Why? Because when I ran nano LabTrain CPP, that's the file name I gave it. So that was the default of where to save it to. When you're done with that, you type Control X to exit out of this editor and you're done. If you now type ls-al, you can see the LabTrain file that you just typed in. You can type cat LabTrain CPP and it'll just list it on your screen, okay? Now you're supposed to put your name in here and, you know, whatever else the syllabus said to put in here and the documentation conventions and stuff like that, right? I'm going to leave it the way it is for now because I'm lazy. Okay, what are we supposed to do? There's your Control O and then Control X, right? And then you want to compile and link the program and make it runnable by entering in this command right here, okay? There you go. I copy it and paste it. It ran. Now we type ls-al again. You'll see it created this file called LabTrain right here. Over there you can see it says rwx. What this means is it's readable and writable by myself and it's also executable. All right. This file down here is readable and writable by myself, but it's not executable because there's no X right there. Now, if you got a file and you want to run it, you simply type in its name. But be careful. If you type in LabTrain, it might say, I don't know where to find it. Why? Because it doesn't know where to look. Okay, if you type /LabTrain, what you're really doing is you're saying, here's a directory. Dot is the current one that I'm in right now, which is, you know, ComSci 463 assign 1, and then /, and then there's a file right there called LabTrain. So this is how you run a program that's in your current directory, okay? And obviously it said hello world because that's what the program does. All right. Now, to save yourself an enormous amount of time, and automate the compilation and other things, you can create what's called a makefile. In this particular course, I'll probably give you the explicit commands. I'll probably also give you the makefiles if there's supposed to be a makefile for an assignment. I'm not going to teach you how to write your own makefiles. That's not part of this course. That's part of other ones. You can use this as a template, copy it and paste it in here, and then write it out into a file called makefile, and then hit Control X to save it. And now we have this thing called makefile. The way these things work is it says down here, you can simply type the command make, and this command looks around to see if there's a file called makefile with a little m, and if it's not there, it'll also look for a makefile with a capital M. Normally, if I write a makefile, it'll have a capital M, and the motive for that is this. If you rename this to a file with a capital M instead of a lowercase m, and you type ls in the directory, the makefile comes first because these are sorted in collating order. Sometimes it's more convenient for that to happen this way. A huge number of projects use capital M makefiles. So you can use the notation that you prefer in this class. I prefer capital M's. All right, so you can see here as I type make, and what it did is it did 2 compilation commands instead of 1. If you want to know how this is all working and what it does, go back to your 241 notes or go to the 501 link in my website that I showed you in the intro, which is up here. And you can read all, where is it? It's in here somewhere. Oh, it's probably in the announcements way up on top. There it is. And in here, there's a lecture and some notes on how compilation and makefiles work, right? How to do assignment 0. This is basically the same kind of thing I'm telling you right now. And somewhere in here, where the heck are the makefiles in here? Makefile right here. There's some notes about makefiles, how to make them, how to use them. All right? Buried in there somewhere. Okay, where were we? We were working on assignment 1. Here we go. and we created a make file. We created the source code is in there. We got a make file. The make file worked. I typed make and it ran. If yours doesn't run, read closely these notes in here. I'm not going to read this entire web page to you. If you get missing separator and so on, it means that when you copied and pasted this, this spacing over here is a tab. A tab is mandated in here, okay? You can't put a bunch of spaces right there, okay? One and only one tab followed by what's called the recipe body over here, okay? That's what that's all about. You have a problem, read the doc, okay? So we were able to compile it, we were able to run it, and this is another thing that's very handy about make files. Once you get these things done and all running correctly, you can have a nice make clean command which cleans up your mess. Your executable files, get rid of them because they're wasting disk space. They're usually much larger than the source code, and even in this trivial program, right, is 17 kbytes. You do have a quota on disk space on these systems. So if you make clean and get rid of all your executables and object files and things like that, you'll save yourself a lot of disk space. Okay. So how do you assign, or how do you rather hand in your assignments? Okay, there's a detailed walkthrough that you saw earlier. There's a link to it right here. Okay, read through that at your leisure. The way you do this is you go into the directory with the assignment and you do a make clean to get rid of the extra junk, because you don't want to hand in that extra junk. I don't want it. You don't want to waste your disk space and so on. See the CD ... That means go to the parent directory of where your assignments are. So right now, here's my current directory. I'm in my home directory / CompSci 463. And in here, there's a directory called assign1. I know it's a directory because there's a little D over there, right? And I made it earlier, and I remember what I'm doing. And if I type ls-al*, that says list all the files in all the directories that's in the current directory. So what this does is it says show me all the stuff that's inside the assign1 subdirectory over there, okay? So I can look around and see what I'm doing. Okay, great. Now I can run mailprog 463 assign1. And the reason we put the assign1 in here is because that's the name of the directory that has the files in it that I want to send. It's not because I'm handing in assignment 1, okay? You could call this XYZ, it doesn't matter. You have to tell mailprog the name of the directory that has your files in it, okay? When you run this, it'll ask you, what is the program number? You need to put the right number in here. Otherwise, we will not get your program, we will not grade it, and it'll be a missing program and you'll end up with a 0. If you screw this up, just run it again and do it the correct way. Oh, maybe this is really assignment 2. That's okay, all right? Just run it a second time. We will keep, if you hand in a piece of garbage, like I accidentally called it 2 and it's 1, or 1 it should be 2. Like I said, you can run it again. If you modify your assignment, oh, I should have done such and so, or I forgot the docket, hand it in again and just say it's assignment 1 or whatever it's supposed to be. You can do this repeatedly. We'll get all of them, and we'll keep the last 3 things that you submitted, for an emergency backup. But think of it in terms of, we're going to grade the final and last thing that you submitted. Okay, including even if it's late. If you handed in 5 of these and then you kept handing it in even after the due date, whatever the last one is that you handed in will be graded. And like I said, if you hand it in late, you'll end up with the late penalty applied to your program. Okay. So don't be confused about that sort of thing. Okay, this is really all there is to it. At this point, I have just completed assignment 1 in its entirety, and if you did it while you're watching this video, you will have done it, and you'll get an A on this assignment as well. Okay, then you type exit or log out to disconnect from the remote host. You are now done. You've logged in, you did your work, you handed it in, you compiled it, all that. You made a make file, you cleaned up the executables out of there and handed it in. And this is all there is to it. So thanks for watching, and I hope you do well with assignment 1. If you have any problems, you can't log in or anything like that, contact your TAs or myself. Now, there's one thing I didn't tell you yet, and that is if this is the very first time that you're connecting to Hopper and Turing, what's your password? Okay. In order to find out your password, you need to log into Blackboard, and there'll be an announcement in there for this course that tells you what your password is supposed to be the very first time. If you've ever used Hopper and Turing before, your password will be set and left to whatever it was set to the last time you used it. If you forgot what that is, go back to the syllabus up here and contact the system administrators and tell them you need your password reset, right, in your account, one of these guys right here, or both as needed. All right, so thanks for watching. See you next time. Good luck.